Today we are going to explain about operation of PNP transistor. This is the circuit diagram of PNP transistor. PNP, emitter base collector junction transistor. Okay. The forward bias applied to the emitter base junction. The forward bias applied to the emitter base junction of a NPN transistor causes a lot of holes from the emitter region to cross over to the base region. Okay, emitter base to the base region. As the base is lightly doped with n-type impurity, the number of electrons in the base region is very small, and hence the number of holes combined with electrons in the n-type base region is also very small. Hence, a few holes combined with the electrons to constitute a base current IB. Okay, the remaining holes, more than 95% of holes cross over into the collector region to constitute a collector current IC. Okay, thus the collector current and base current when summed up gives the emitter current. So IE equal to minus of IC, IE equal to minus of IC plus IB. Okay. What is the operation of PNP transistor? PNP transistor. The forward bias is applied to the emitter base junction of a PNP transistor, causes a lot of holes from the emitter region to cross over to the base region. As the base is lightly doped with n-type impurity, the number of electrons in the base region is very small, and hence the number of holes combined with the electrons in the n-type base region is also very small. Hence, a few holes combined with electrons to constitute a base current IB. The remaining current base current IB. This is the base current IB. Okay. The remaining holes, more than 95%, cross over into the collector region to constitute a collector current IC. Okay, IC. Thus, the collector and base current when summed up gives the emitter base current IE equal to minus of IC plus IB. Okay. In the external circuit of the PNP bipolar junction transistor, the magnitude of the emitter current IE, the base current IB and the collector current IC are related to IE equal to IC plus IB. IE equal to IC plus IB. Okay. This equation gives the fundamental relationship between the current in a bipolar transistor circuit. Okay. This equation gives the fundamental relationship between the current in a bipolar transistor circuit. Also, this fundamental equation shows that there are current amplification factors. Okay. Current amplification factors alpha and beta in common base transistor configuration and common emitter transistor configuration respectively for the static DC currents and for small changes in the currents. Okay, and in small changes in the currents. Okay. Next we can see the current in PNP transistor. Okay, current in PNP transistor. The circuit diagram of current in PNP transistor is like this. Okay, the circuit diagram of positive, negative. This is IB, this is IC and this is IE. Okay, this is the current in PNP transistor. Okay, the current amplification factors alpha and beta in common base transistor configuration and common emitter transistor configuration respectively for the static DC currents for small changes in the currents. Okay. Next, large signal current gain. Large signal current gain. What is alpha? What is alpha? Okay, alpha is the current amplification factor. Okay, what is this? Large signal current gain. Large signal current gain alpha. Large signal current gain alpha. The large signal current gain of a common base transistor is defined as the ratio of the negative of the collector current increment to the emitter current changes from cutoff to IE. Okay, what is the alpha? Large signal current gain alpha. The large signal current gain of a common base transistor is defined as the ratio of the negative of the collector current increment to the emitter current changes from cutoff to IE. Alpha equal to minus of IC minus ICB naught by IE minus 0. Okay, where cutoff means IE equal to 0. Okay, where ICB naught, where ICB naught or IC naught, ICB naught or IC is the reverse saturation current flowing through the reverse biased collector base junction. That is the collector to base leakage current with emitter open, as the magnitude of ICB naught is negligible when compared to IE. The above expression, can be written as this expression. This expression can be written as alpha equal to IC by IE. Since IC and IE are flowing in opposite directions. Since IC and IE are flowing in opposite directions, alpha is always positive. Typical value of alpha ranges. Typical value of alpha ranges from 0.9 to 0.9 to 0.995. Okay, also alpha is not a constant but varies with emitter current IE, collector voltage VCB and temperature. Okay, this is the large signal current gain alpha. Okay, thank you.